hope everything is just a reminder that this will be part 2 of the exam prep. We did part 1, excuse me, and in part 1 what we did was basically looking into how best can we achieve maximum marks, how best can we reduce the common errors and the misconceptions that are there. So we went into looking at mechanics, and then we emphasized that mechanics will be 93 marks in an exam. And then I therefore gave you the layout of to say where are the marks and which topic has more marks. So we did say something about Newton's laws. We said something about momentum, and we went in depth as to how to go about it and issues that you need to focus on. So now I'm kindly going to continue with work, energy and power and elasticity. Thereafter we'll move to other concepts maybe of paper 2. But surely the issue of us getting marks for mechanics should have been addressed in the previous video. So now this is a continuation of what we did. So we look into the misconceptions like we did before, but the misconceptions now that are related to work, energy and power. It says here, most candidates substituted cos of 90 or sine of 90 instead of 0. The reason for this, it's us not knowing exactly when to use 90, when to use 0 and 180. So the idea is we'll need to look into the question and be able to answer it thereof. Another misconception is the majority of candidates held a challenge in calculating the work net, and then a significant number of candidates omitted keywords like total, isolated system, or remains the same. So if you can see now, we have a trend of omitting keywords. If you check now, we still struggle somehow to calculate work net. But now, if we look into the question that was given to us in the previous exam, it said Jan applies a force of 100 newtons to lift a 5 kg crate from the ground to a height of 0.8 meters above the ground. So the challenge thereof is, before I can be able to answer anything that relates to this particular statement or the STEM given, I should be able to identify all the forces that are acting on the crate. So once I am able to do that, somehow it will be easy for me to identify the direction of the displacement as well as the direction of the force. But I definitely know that somehow a definition needs to be asked in this type of questions. Somehow I need to be informed in terms of how best can I be able to get the maximum marks. So what I've learned is somehow, like the achievables we did before, the question will come to say differentiate between work and energy. So if you are going to differentiate between work and energy, we'll say we'll have work and we'll have our energy thereof, because it's a differentiation between the two. So I'm expected to say something about work, I'm expected to say something about energy. So energy from grade 10, we know that we define energy as the ability to do work. Ability to do work. But now what about work? Work we say is the product of applied force, F applied on an object, and the displacement in the direction of the force. in the direction of the force. So this is me differentiating between the two. But I can easily say work is defined as the product of the force and the angle now between the force and the displacement. It's me now extending it further, because now the direction of the displacement is what will be informed in terms of cos of 0, cos of 180, and cos of 190. Remember, bullet number 1 now said we have a challenge. Most candidates substituted cos of 90, sine of 90, instead of cos of 0. So the question is, when should I be able to substitute a 0? When should I be able to substitute a 90? So I'm going to try and generalize it and make it easy for you to say, for us to use theta is equals to 0 and theta is equals to 180. For us to use that, it means somehow this must be parallel. F must be parallel to the displacement. Parallel to the displacement. This is the key thing. So if it says F must be parallel to the displacement, that means now they must somehow be in a way that they are next to each other in a way. So if they are parallel to each other, I can only consider 0 or 180. That is the first part. But the question will be, when is it going to be 0 and when is it going to be 180? So it will be 180 when F is in an opposite direction with displacement. We need to get that one clear. So if the direction of the displacement and the force is in opposite directions, then it means I must use 180. And then it further says, now for me to use 0, then it says F is in N, or it's in the same direction as displacement. Then I can use my 0. Because the issue of cos of 90, it's us saying if we substitute 90 into this equation, everything now becomes 0. So it's a misconception that all the time when we are working with forces that are vertical, we need to substitute cos of 90. That is not true, because we need to check now the direction of the force as well as the direction of this displacement. So if the direction of the force is in an opposite direction with the displacement, then we will use cos of 180. If the force and the displacement, the direction of the displacement are in the same direction, then we will be able to use now cos of 0. So if this is clear to you, when to use 0 and when to use 180, it is easy for you to answer questions that follow. But somehow, not somehow, mostly and importantly, you need first to draw a free body diagram. The reason for drawing a free body diagram, whether asked or not, is for us to be able to identify the direction of the force, the forces that are doing work as well, and be able now to choose the correct angle for our theta. So first thing is we draw a free body diagram. From the free body diagram, we identify now forces doing work. So if I am able to identify the forces that are doing work, it becomes easy for me to know in terms of which direction can I use and the information that is given. Is it going to be a cos of 90, cos of 0, cos of 180? So that is the most thing that we as learners, we struggle with in terms of when to use a 90, when to use a cos. And remember, the formula will always be given in the formula sheet. So all you need to know is when to use 0 and when to use 180. So I'm going to try for us to solve this principle or this question that is given and check if we are able to apply what we just discussed. So at 5.212, it says calculate the net work done on the crate. But we said the first thing to do is to draw a free body diagram. So this will be 5.12. I am going to draw a free body diagram. From the first part of this video, we said a free body diagram is identified with a dot. Hence, I am starting with my dot. And then remember, we said now as a misconception or a common error, the arrows must start from the dot. So what do I have? I have this force applied by Jan, and then I have FW from the crate. So these are the only two forces that I have. And the direction of the displacement, is upwards. I always try to write it somewhere also to say, but now this is the direction of the displacement. So it makes my work easy to say, but now F applied, it's in the same direction as the displacement. But FW, it's in an opposite direction with the displacement. So this assists me in terms of when do I have to use 180 and when do I have to use 90. Because we did say I can only use 90. Maybe I should add it here also to say we can use the theta 90 only when we have F perpendicular to the displacement. So once we have that, is then that we can use theta that is equals to 90. So in this case, we don't have a force that is now perpendicular to the displacement. So it means I am only looking at 0 and 108. So remember 0, the force, it's in the same direction as the displacement. Then 180, if the force, it's in an opposite direction with the displacement. So with that being said, it makes it easy for me to say, but they are asking for work net. So it means I must calculate work done by individual forces. And then at the end of it all, I must just be able to combine everything. I prefer doing it that way because if I make a mistake in calculating this, it's a mistake that I can easily go and correct, and I'm not complicating things for myself. So I am going to calculate work done by FA, individual forces. So it will be FA multiplied by changing X cos now of theta. Then I substitute The value is 100 multiplied by the displacement is 0.8 cos now of 0. Why cos of 0? Because force applied, it's in the same direction as the displacement. Then I will be able to get my answer. My answer is something like 80. But now what is the problem with this answer of mine? Remember, we go back to our principle, our analogy of F sort. So it means what must follow is I have my substitution, I have my I have my formula, I have my substitution, I have my answer. So what do I need? I need the SI unit, and work is calculated in joules. Then I further move on and calculate work done by FW, which will be FW multiplied by changing X cos of theta, which is equals to FW is equals to mg. So we have 5 multiplied by 9.8 multiplied by the displacement, which is 0.8 cos now of theta. But now what is our direction of theta? Remember, I can only use 0 and 180 into this equation, because once I substitute 90, then it complicates things and there's no work done. Everything thereof will be 0. So what do I need to do? It's best for me to say, but now the FW, it's in an opposite direction with the displacement. So I must use cos of 180. Then everything thereof will be negative 39.2 joules. There are many ways of doing this, but preferably I prefer this one so that I don't complicate things for myself. You can do this in 1 step or 2 steps, but I prefer to calculate it for each and every individual force, because I can assign now each value of the angle to each and every single force individually. And then remember, I said once we have a sequence of working, once we have an approach that is clear, it means you will be in the correct direction of getting the right answers. Then they said they want work net. So work net, I just know it is work done by FA plus work done by FW, because net, we said it is the sum of everything. So it is the sum of work done by the force applied, work done by FW. Then it will be just 80 plus minus 392, and then eventually our answer will be something like 40.8 joules. So it becomes easy provided you are able to identify when to use 180, when to use 0. So I said, even if a free body diagram is not asked, it's easier for you to draw a free body diagram and check the direction of the displacement against the direction of the force. Then you will be able to know when to use cos of 0 and cos of 180, because the mistakes that we are doing is the same one of saying, because now these forces are acting perpendicular to the ground, not the displacement, to the ground, so automatically we'll think that we must use cos of 90 or even sine of 90. So that is not correct. It's another misconception or another common error that we do, and we lose marks. So it is important first to check if your forces now are perpendicular or parallel. So once your force is perpendicular to the displacement, then it is going to be theta will be equals to 90. But we only substitute, I will emphasize that, we only substitute for our case in terms of the calculations, we only substitute 0 and 180 into this equation. So once you substitute 90, remember no work is done unless you are being asked why perpendicular forces are not doing work. So that will be because of F is perpendicular to the displacement, and then thereof you substitute cos of 90 here, then everything becomes 0. So with this one you only get a +1 and a -1. Then it indicates that part of direction when you say F is in an opposite direction with the displacement, as well as saying with 0 now, F it's the same direction as the displacement. So kindly remember that in this equation of work, we can only substitute 0 and 180. So it's a misconception that the forces were acting perpendicular or they were acting up or down. So now majority of us decided to use cos of 90, of which in this case it was not true, and you omitted the SI units thereof. So I did not omit any SI units because I have a principle that I am working with. So for me to eliminate all these small mistakes that I'm doing, I am generating analogies and sequences that I am using for me to be able to answer this. So once you create that, it is the understanding of science. Once you are able to work through this sequentially, it means you definitely understand what you are doing. And that is what we want, because questions will change over time. Some new questions will come. So the idea is for you to have a broader picture of what the examiner is trying to achieve. So we can look into the memo just for the purpose of giving you different options. So my option, I think, is option number 3, where I calculated for individual forces. And then this is option 1, where you go straight into work net is equals to changing F net. But now the challenge here is you still go back to work done by FA and work done by FG. So the challenge with this one is if you miss now that part of individual forces here, everything is going to be completely wrong. Hence, I always try break it down into small pieces that you are able to chew. Then option 2 also calculate the F net first and then take F net into this equation. But now the question is 1. When can you tell this was supposed to be 0 or 1? Then it goes into you understanding Newton's second law, or how vectors work in terms of the direction and everything else. Because from the free body diagram, hence I made this one somehow longer, it says my net force will be in the direction upwards. So if it's upwards, it's still in the same direction as the displacement. So somehow it becomes complex, but it is still the science that you can be able to apply. But provided you know exactly what it means for you to have that 51 as your F net, because we assign now F net also with direction, because it's a vector. So hence it's important for you to understand that where this -1 comes from. So preferably this is how I will go about it, because I understand each and every single part that comes thereof. And let's move on. An Olympic diver with a mass of 60 kg dives from a platform 10 meters above the water surface. Ignore the effects of friction, or of air resistance, sorry. Then state the principle of conservation of mechanical energy. It says here as a misconception, most candidates failed to apply energy principles to calculate the final velocity. A notable number of candidates were unable to use conservation of mechanical energy equation to calculate. A substantial number of candidates only calculated EP or EK instead of EM. Other candidates used the wrong formula. Instead of using ME at A, they used MA EP plus EK. So the problem with this as well, I will go back to that question of momentum that we did. A notable number of candidates had a difficulty of stating the principle of conservation of linear momentum. Some confused the principle of conservation of linear momentum with the principle of conservation of mechanical energy. So the same mistakes that we are doing here when we talk of conservation of linear momentum is the same mistakes that we will do when we talk of conservation of mechanical energy. We will still omit the keywords isolated and total. So it is important for us to go back and look now into exactly what is it that is expected out of us. So stating the principle of conservation of mechanical energy, we should be able to say the total mechanical energy of an isolated system is conserved. 2 marks. And we go back and look into the marking criteria thereof. The word total should be there with mechanical energy. Isolated system must be there, and then the system remains constant. So if it happens that you omit any of the keywords, you'll still go back and forfeit now another mark. So we don't want that. We want you prepared for the examination that is coming. So the idea is, let's have the definitions as per the exam guideline. Let's have our definitions as per terms and definitions that were shared with us during the course of the year. So the total mechanical energy in an isolated system remains constant. Easy 2 marks. Now I am going to try and answer this question, and the way I am going to do it, I am going to do it in such a way that I get it wrong, to show you the misconception of this. The question says, use the principle stated in question 5.2 and calculate the diver's speed when he hits the water. Fine. I have the 10 meters, and then I have my water here. And then I have the diver somewhere here at the top. It's about to come down. So I need to assign each and every velocity here, or information given. But remember, I said I am deliberately going to make it wrong to show you that that is not the principle. So I am going to say mechanical energy is equals to EK plus EP. And then I therefore say this is half mv squared plus mgh. Then I further go on and say half of the mass of the diver, which is 60, v squared plus 60, 9,8 multiplied by 10. Ne? And then somehow, because we have this misconception of saying the mechanical energy is isolated and it remains the same. In an isolated is conserved and then it remains the same. Somehow, some learners eventually have a 0 here. Then from this 0, they decide now to equate everything and eventually get VF, which is equals to 14 meters per second. So what is wrong with this? The answer looks correct, but what is wrong with this? What is wrong with this is you did not apply the principle itself. This is not the conservation of mechanical energy. That is the thing. The conservation of mechanical energy should be followed by the sum. Hence we say the total. The sum of mechanical energy before is equals to, or we can easily say mechanical energy initial is equals to mechanical energy after. EA after. But what is this mechanical energy? It's the sum of EK plus EP. So I can easily say EK plus EP initially, or even at the top, let me write it at the top, is equals to the EK plus now EP at the bottom. So this is the principle, because it says now the total mechanical energy in an isolated system remains constant, or the sum of gravitational potential energy and kinetic energy in an isolated system remains constant. So the difference already can be seen that I am applying the principle here. The mechanical energy before should be equals to the mechanical energy after. So what does this say here? It doesn't necessarily say it is the principle. It just says the mechanical energy at mechanical energy is equals to EK plus EP. It's not saying that. It is not. Hence, somehow you'll get the correct answer. You only get the correct answer because now if we check, now we need to associate values here. Half of mv squared plus mgh at the top is equals to half mv squared at the bottom plus mgh at the bottom. So let's substitute our values. Half mv 60 multiplied by 0 plus 0 because the diver is at rest at the top, and then you have 60 9,8 multiplied now by the height, which is 10 meters, which is equals to half of 60 v final is what we want, v squared plus now something like 69,8 multiplied by 0. And we know that everything multiplied by 0 is 0. So this will cancel and this will cancel. Then eventually you are left with everything. So VF will be something like 14 meters per second. So this is me applying the principle. If you did not do this, you did not apply the principle. I came across this answer somewhere of a learner who did it this way. So the challenge was, but the final answer is somehow correct according to this particular learner. But is the principle applied correctly? No, it's not. Because it clearly says to me, the learner does not understand exactly what it means when we say the total mechanical energy in an isolated system remains constant. So with this, eventually they get the correct answer, and then it is not how it works, because this is not the principle. This is just a mere definition of what mechanical energy is. So for us to use the principle, it means we need to have this sum of the two at point A, the sum of the two at point B. Hence, we are able to say the mechanical energy before should be equals to the mechanical energy after. So the question now came to, how do I give this learner a mark now? How do I give this learner a mark? Because eventually I must give this learner some marks also. But the challenge is this V here, the 14 that the learner got, does not correspond with the 10. Because the height of 10 is when the diver is at rest. So I cannot give any mark here for substitution, because the value the learner got of V final at the bottom does not correspond with this particular 10. So the only thing that I was able to do was to give this learner just 1 mark for all the efforts the learner went through. So to avoid us losing marks, because this learner now lost 3 marks because of this particular misconception. So to avoid that, let's apply the principle. And if we apply the principle, it's easy for us to say we will give you 1 for notably writing down the principle. 2, for us to have it the right way. The velocity at the top is 0. The velocity that corresponds, the height that corresponds to that 0 is 10. Then we will be able to give you another 1 mark for the substitution here. And this velocity corresponds now with 0. That is now when the diver is in the water. That is the reason why we will give you again another mark here for that particular substitution. Then the final answer will be also 1. So majority of you were doing option number 1, of which option number 1 is completely wrong, because it's not the application of the principle. So application of the principle, remember, we want to see the sum of the 2 being equals to the sum of the 2 at the top and as well as at the bottom. So you lose a lot of marks in work energy and power because of this particular problem thereof. So it makes your life somehow complicated and complex, because honestly, if we cannot apply the principle, automatically we are losing marks. Hence the question was very clear: use the principle stated in 5.21. So we lost a lot of marks there because we did not apply the principle. And according to the math that I know, if you transpose now or bring everything you get here into the left and the square root, somehow you are going to get an error there, because a square root of a negative is undefined. So somehow the learner managed now to get to this particular answer. I don't know how, but it's one thing that I came across. So I'm already clearing it out to say, if you are going to work with the principle, and I'm saying there's a misconception somehow related to the use of mechanical energy. And that misconception is the misconception that is making us now not to get maximum marks. So let's correct it. It's not the right way of applying the principle. We lose a lot of marks. So let's follow this option that I clearly indicated the distribution of marks. I clearly indicated how the principle should be applied. So I'm hoping that from here on, you will not continue doing the same mistake, because if one learner did it somewhere, it means it's something that is circulating and can be done moving forward. So let's avoid that. It's not a right way of doing or applying conservation of mechanical energy. So that was it with question 5 about work energy and power. So, but remember, we can further extend the questions here, 5.23, and say now calculate power, and things like that, but some information will be given. So when you study, use your exam guidelines and check in the topic what is it that you need now to understand and know. Did I apply my FSOT? Yes, I did, because it says here other candidates wrote incorrect SI unit and omitted the SI unit altogether. So it is persisting, it is coming up again. So with my FSOT, I have my formula, I have my substitution, I have my answer, I have my SI unit, because it's a speed now, it's just a scalar quantity, then no direction needed thereof. And one other thing is, some learners, they did not use 9,8 here. Let me write it down, show it to you. They wrote 9,89, and others wrote 9,90, others wrote 9,9, so instead of using the 9,8. So kindly refer G in your formula sheet as 9,8 meters per second squared. So no any other value, it will just be 9,8. So I don't know where these other learners got this, but it's something that I came across as well. So we are trying to minimize the mistakes as possible, as many as we can. So please, now moving forward, apply the principle accordingly. Don't use this particular method. It's not right. You will lose a lot of marks with something that you were able to do as well. So expose yourselves to high order questions that wants you to use more of mechanical energy, the conservation of mechanical energy. So that is it with question 5. We'll go to question 6. And question 6, it's based on elasticity and viscosity. So let's go and look into the misconceptions thereof. It says to me, keywords were omitted from the laws and definitions, for instance, regain, deforming, and property of the body. Most candidates failed to convert to the correct SI units. Now comes another dimension of conversion. We are failing to convert to the correct SI units. Most candidates have a difficulty of choosing the correct formula to calculate the area. So we have a problem of calculating area because we do not know which formula to choose, and candidates were unable to determine the effect of temperature on viscosity. So these are the common errors that we are exposed to. So I'm going to try and see if I can't help you with that, or in that regard, for me to be able to help you in terms of the exam that is coming. Because remember, with these exams, you only have one opportunity and one opportunity only. So it's always best for us to prepare ourselves and get the maximum marks that we can be able to get. Let's look into the question then and check if exactly how best can we answer this particular question. It says now, when a deforming force is applied to a body, a restoring force develops inside the body to oppose the effect of deforming force. Define the term elasticity. So elasticity is defined as a property of a body by virtue of the body to regain its original shape and size when the deforming force is removed. So you can easily tell. We said here, majority of you omitted keywords like regain, deforming, and property of a body. So you can imagine if now you are giving a definition and say a virtue by of the body to regain its original shape and size. It does not say anything about elasticity. You see, hence it's important now to be able to say, let me have all my keywords within the definition itself. So the only definition here will be a property of a body by virtue of the body to regain to its original shape and size when the deforming force have been removed. So the keywords there are very clear. A property of the body, regain to its original shape and size, and deforming force removed. So if you don't have any of the underlined words, everything now becomes complex, everything becomes difficult for us to mark and award you the marks that you deserve. So it's somehow also challenging in that regard. Then at 6.2, distinguish between a perfectly elastic body and perfectly plastic body. So the only way of differentiating, we said it's best to always give the definitions of the two. Give a definition of what is a perfectly plastic body. Give a definition of what is a, what's the other one? Perfectly elastic and perfectly plastic body. So it's important to say now a perfectly plastic body regain its original shape completely when the deforming force is removed, and then a perfectly elastic body, a perfectly plastic body does not regain its original shape and size when the deforming force is removed. So you can just basically correct the two here. I think it should be perfectly elastic. Perfectly elastic body. Perfectly elastic body regains its original shape and size when the deforming force is removed. And then perfectly plastic body does not regain its original shape when the deforming force is removed. So the only way of doing that was basically to differentiate or give the definition of what is a perfectly elastic body as well as a perfectly plastic body. Let's move on. And then we are given now a cylindrical wire with a length of 1,500 millimeters experiences a stress of 9.5 kilopascal when a force of 12 kilonewtons is exerted on it. And remember, it is being said that most candidates had a difficulty choosing the correct formula for area. So the best thing to do is to check what information is given. So at 6.21, I will say, what is it that I have? Do I have a force? Yes, I have a force which is 12 kilonewtons. What else do I have? I have stress, which is now 9.5 kilopascal. And then what is it that they ask me? They're asking me now to calculate for area of the wire. So it becomes difficult if you don't know which formula to go to. But all formulas, remember, are given in the formula sheet All you need to do is familiarize yourself with that. But it further goes on to say most candidates failed to convert to the correct SI units. Remember, everything now should be in the correct SI units. So what must I do? I must multiply this one by 1,000 for me to get 12,000 newtons. I must now multiply this one also by 1,000 for me to get something like 9,500 Pascal. So in so doing, I have already eliminated the issue of converting to the correct SI units, because all the equations that I have, the idea is they must be now in Newton and Pascal, or they must be in the correct SI unit thereof. So there are a lot of principles or analogies that you can use to know how to convert from the correct to the correct SI units. Some learners use King Henry died a miserable death, so called measles. So there are a lot of things that you can use for you to be able to know exactly how to convert and when to convert. So there's quite a lot of analogies that we have for us to be able to know how to convert. So kindly go and research in terms of how best can you remember and memorize your work in terms of converting to the correct SI units. So with this being said, it becomes easy for me now to say I have a formula that says stress is equals to F over A, which is equals to 9,500 and then 1,2,0,0 over A. Then I can do the mathematics, and then 1,26. It's just like that. But now remember the F sort. What does F sort say? F sort says to me I must have my formula, my substitution, and my answer with what? With the SI units. What will be the SI units for area? Square meters. Then it's only then that I will be given the mark of a final answer. So the key idea here was just for you to be able to convert to the correct SI units. At 6.21, the length of the wire is increased by 12 centimeter when the 12 kilonewton force is applied on it. Calculate the strain it experiences. The strain it experiences. So this one is quite easy. 6.22, the equation for strain, we only have one. It's changing length over the original length. So we were given the length as 1 comma. Now I must write it down nicely to say we had the initial length as 1,500 millimeters, and then it increased. Now the change, okay, let's say increased by 12 centimeters. So you see, there comes now a challenge of I have two different units now, millimeters and centimeters. So what must I do? I must convert them into meters and be able now to use them correctly. So with that, I will have something like 0,015 divided by 1,5, which is just 0,01. And it does not have any unit because it's length divided by length. So it's basically that, 100%. So let's further move on. Then it says define the term viscosity. The property of a fluid to oppose relative motion between the two adjacent layers. So it's just the definition as well. So the key thing to look for is keywords and write it as it appears in the exam guideline. Then we'll increase in heat on the mixture cause the viscosity to decrease, increase, or remain the same. So the answer is going to decrease. It's going to decrease because it's a lotion, so it's going to become somehow harder, a body lotion. So once it becomes harder, it means the viscosity is going to decrease because it's no longer going to be able now to flow. So the correct answer here it's a decrease, because they are saying two girls wants to produce a body lotion from affordable materials. They decant the location into a smaller containers and increase the rate of flow. The temperature increased. So that is what now they are asking us there. So that is basically it with elasticity. That is basically it with elasticity. Now let's look into hydraulics. Let's look into hydraulics. Hydraulics candidate lost marks for omitting key phrases like continuous liquid at equilibrium or transmitted equally when stating Pascal law. So it means when we are stating Pascal law, the mistake that we did not have the words continuous liquid at equilibrium or transmitted equally. So that became now a challenge to us to say, but now we are not able to state Pascal law, and if you are unable to state Pascal law, it means you are going to lose marks for that, because the very first question here was state Pascal law. So stating Pascal law, quite easy. In a continuous liquid at equilibrium, 1 mark. So the key point there, key bullet. The pressure applied at a point is transmitted equally to the other parts of the fluids. So it's a definition, straightforward, and somehow it should be quite clear as to how to go about it. And then at 7.2, it says calculate the pressure in the container at 20 centimeter height if the density of the water is 1000 kg meter cubed. So it's very easy as well, because what we are given the height, we are given the density, and we have our G, so our answer will be 1960 Pascal. Quite easy and straightforward. Just remember to apply a sort formula, substitution, as well as now the final answer with the correct SI unit. But there wasn't much of learners struggling with this, so I'm going to go straight and show you that this part of 7.2, the pressure in the car 4 tires is 2.2 bar each. 2.2 bar each. So now the challenge here was convert the pressure to atmospheric pressure, and 1 bar is equals to 10 to power 5 Pascal. So with this already, the examiner is giving us an indication of how easy or how best can we be able to get this 1 mark. But in the near future, we will not be given this. The question will be just now convert the pressure to the atmospheric pressure. So it means I need to know all the constants to say if I want to move from a bar to Pascal, this is what I am multiplying with or dividing with. If I am moving now with kilopascal to Pascal, then definitely also I should be able to say this is what I am now looking into. So for this one, it was quite easy because we had a hint there of saying 1 bar is just equals to 10 to power 5 Pascal. So each car has, okay, the car has something like 2,2 bar. So I just wanted to know this. So my x eventually became something like 2,5 multiplied by 10 to power 5 Pascal. And then it was just 1 mark for this one. So that one was not a challenge, but because the question came here, it says the examiner is aware that we are failing to convert to the correct SI units. Can you see that? So kindly ensure before you go into the examination, you are able to convert to the correct SI units. Because if you do not have the correct SI units, it means now everything will not fall into place correctly, and then somehow you will start losing marks for that. So we can go directly to 6.4 because 6.22 everything is quite clear. I didn't see any one of us struggling with that, but the problem came now when we're working with 7.3. So when we're working with 7.3, what I found out was where is it? It's here. Most candidates had a difficulty of choosing the correct formula for the area. So it came up again as a part of that because when you read this particular question, it's based on hydraulics as well. The hydraulic lift in a diagram below, it's like the hydraulic jack of a car. It has a diameter, we are given now a diameter of 0.25 at piston A, and then a diameter of 1.0 m or meters, sorry, at piston B. A block with a mass of 250 kg is loaded at piston B. So now that becomes a challenge to say majority of us we did not know because we're able to choose the correct formula to say I have F1 over A1 which is equals to F2 over A2. Majority of us were able to do this. But now substituting the correct information into this was a challenge. Remember, we are given now a diameter. Let's look into this particular circle of mine. So a diameter is the sum of the two radius. So I'm going to have this radius here and this radius there. So what does this mean? It means now my diameter is equals to something like 2r. So it's either you first now get the r, because now the challenge that we have is the area of a circle. Area of a circle is equals to pi r squared. So the first thing is now I need to move from a diameter and work with my radius. So the challenge is choosing the correct or writing down the correct equation for a circle. Today it's a circle, tomorrow is going to be a square, it's going to be a rectangle. So kindly be informed on how best can you go about calculating for areas and the radii thereof. So it means in this case now it becomes easy to say for piston A I have a diameter now of 0 0.25, which is equals to 2r. Then my r is something like 0.125. Then it's easy for me to calculate the area to say area of piston A, okay, piston A is equals to pi 0.125 squared. Then I can get my area and substitute now into that. So the mistakes that majority of us did was we unable to calculate the area of a circle from the diameter that was given. So the first thing was, from the diameter, let's get the radius, and the radius we are able now to substitute into this particular equation. So that is the mistakes that majority of us did, and somehow we lost a couple of marks, and we can be able to solve this particular challenge moving forward. So if you check now from what we started with, so this was basically something like 16 marks together with the first part we did on elasticity. So if you check, we are able now to go back and refer and say Newton was done, momentum was done, work energy and power was done. So I can easily say also, but we did now just completed elasticity, viscosity, and hydraulics. So I believe that moving forward, everything that has to do with mechanics, you will be able to get maximum marks, because now it's 93 out of the 150. The intention was, I will also want, when time allows, for us to look into electricity and magnetism, but I feel that somehow let's go and look into organic chemistry, such that we can get maximum marks there as well. So this now will be the end of this video. The idea is we tried majority of topics in paper 1, and remember, in paper 1 mechanics will be 93 marks out of 150, and it's your Newton's laws, momentum and impulse, work, energy and power, and elasticity. So we still have light and waves, sound and light, and we still have electricity and magnetism. But the key idea is, look into your exam guideline. It clearly states that mechanics is 93 and electricity and magnetism is 33. So when you plan your revision moving forward, kindly use your reports, where your your examinable content, your exam guidelines, because your exam guidelines will assist you in terms of getting right definitions and the approach thereof. I hope part 1 and part 2 of this video assisted you somehow. Part 3 will be based on part 2, which will be 75 marks. So we'll look into organic chemistry and see how best can we assist you in that. For me, all the best, and then we will meet in a couple of minutes. Thank you very much.